Hey, glad you could join us. I've been looking forward to this. There's something calming about sharing space stories with someone who's curious too, so thanks for being here. It's always nicer to explore the stars together than alone, don't you think? We'll take it slow, let our minds float a little, and just see where the journey takes us. No rush, no pressure, just wonder. If you like listening to quiet stories about space and stars, please tap the like button. It helps others find this peaceful place too. And if you want to come back for more calm journeys through the universe, please like and subscribe. Enjoy what I do here, and let me know in the comments where you're tuning in from and what time it is for you. It's always fascinating to see who's joining us from around the world. Hey everyone, today we're looking into stars, but not just the ones glowing softly like lanterns in the night. We're going beyond that, way beyond. Past the swirls of galaxies, past the places where light begins to stretch and slow. We're gently floating toward the edges, or at least what we think might be the edges. Because that's the question, isn't it? Does the universe even have an edge? Or is it endless, stretching on forever like a dream without a waking point? Come with me. Let's take a slow breath together and imagine we're standing on a quiet hillside on Earth. The grass is soft beneath us, the air cool against our skin. Above, the stars are coming out one by one, like tiny candles in the sky. It's peaceful, the kind of peaceful that makes you want to ask big questions without needing fast answers. Now tilt your head back. See that one star there, just above the horizon? That one's part of our own galaxy, the Milky Way. And beyond that, there are more. More stars, more galaxies, more everything. Or maybe not. That's what we're going to gently explore tonight. Picture yourself drifting upward now. Slowly, effortlessly, the ground fades behind you. The sky turns deeper. You pass the clouds, the upper atmosphere, satellites blinking like fireflies. Then you're above it all, floating in space. There's no sound here, just the quiet presence of everything. Beneath us is Earth, blue and glowing. Above us, nothing and everything. The stars don't twinkle here. They shine like holes poked through a curtain. They're steady, honest, infinite. Let's see. You might feel the pull of curiosity, like gravity for the mind. What does it mean for something to be infinite, anyway? When we say the universe might go on forever, we don't mean just far. We mean forever far, as in no end, ever, no outer wall, no curtain to peek behind. Just more stars, more dust, more darkness, forever. Now breathe with me for a moment. In and out. Let your shoulders relax. Feel the quiet of space wrap around us again. We're drifting on currents made of light and time, and none of it is in a hurry. You don't need to understand it all. You just need to feel it. Tilt your head slightly. Can you sense how the darkness here isn't just black? It's layered, deep. It's like velvet, soaked in secrets. And between those layers, there's movement, slow, ancient motion. Galaxies aren't still. They're sliding away from each other, carried on the swelling fabric of space. You see, when we say the universe is expanding, we don't mean it's growing into something. It's not pushing out into empty space like a balloon into a room. No, space itself is stretching. Every bit of it. Like dough rising in an oven, everything inside gets farther apart. Even galaxies that aren't moving through space are being pulled apart by space. Reach out again. Let your thoughts graze the edge of a galaxy far older than ours. See how its arms are faint, almost faded with time. Some of its stars have already died. Their light is still coming toward us, but their lives ended long ago. We're looking at ghosts made of starlight. Now look past it, farther, past the glowing clouds, past the last points of light, to where the dark gets darker. That's where the cosmic microwave background lives, the oldest light we can see. Not stars, not galaxies, just warmth from the baby universe, glowing faintly in every direction. Feel how ancient that light is. It's over 13 billion years old, a soft afterglow from the Big Bang, stretched and cooled by the expanding universe. It's not hot anymore. It's barely above absolute zero. But it's still there, whispering. Let's drift through that light like dust in a sunbeam. You and me, floating where time begins to blur. Here, even the silence seems to hold a memory. And yet, beyond even this we don't know. We can't know. The light from farther out hasn't reached us yet. Or maybe it never will. Maybe it's trapped behind an invisible curtain we'll never pass. That's what we mean when we talk about the observable universe. It's not a limit to the universe. It's a limit to us, to what we can see, measure, feel. But just because we can't see it, doesn't mean it's not there. So, is the universe infinite? Maybe. Or maybe it's just so huge that, for all practical purposes, it feels infinite. It stretches so far that we can spend a lifetime, many lifetimes exploring, and still never touch the edge. Let's turn now, slowly, and face another cluster of galaxies. Watch how they shimmer like distant cities at night, connected by faint bridges of dark matter. These filaments stretch across space, forming a cosmic web vast and delicate, like frost across glass. It's beautiful, it's haunting, and yet, it's real. Feel how your breath slows here. The silence deepens again. We're not racing, we're just being, observing, wondering. This moment is a kind of stillness you can't find on Earth. No traffic, no clocks ticking, just light and gravity and time. You might ask yourself, if we can't ever see the edge, does it matter if there is one? That's a good question. Maybe what matters more is how thinking about it changes us. Maybe infinity isn't something you prove. Maybe it's something you feel when the stars are too many to count and the darkness never runs out. So float with me here, just a little longer. Let's not worry about answers. Let's just keep drifting, keep looking. Because the more you look, the bigger it feels. Not just in size, but in meaning. The universe holds everything, every story, every atom, every dream. It's not just wide, it's deep. Deeper than numbers, deeper than names. And we're inside it. Not outside observers peeking in, but part of it, made of stardust, moving with it, glowing quietly, like one tiny thought in the mind of something vast. So here's what we know. The universe is old. It's expanding. It's filled with light and matter and energy and mystery. The part we can see is enormous. The part we can't see might be endless. And the truth is, even if we never find out for sure, even if the answer stays just out of reach, we still win. Because we asked, because we looked up, because we cared. So tonight, when you go outside and see a star, just one, remember this journey. Remember that you've seen galaxies spin. You've felt the hush between worlds. You've looked into the curve of space. And maybe, just maybe, you've brushed against infinity. But we're not done yet. Let's glide sideways now, toward a place where even light has trouble keeping up. This is where the expansion of space itself begins to outrun the speed of light. Galaxies here are moving away from us so fast that their light will never reach us, ever. They are, in every way that matters, gone, not destroyed, just out of reach, pulled over the edge of what we can know. It's like standing on the shore and watching a boat vanish over the horizon. You know it's still out there, but you'll never see it again. And that's another kind of infinity. Not the kind where space goes on forever, but the kind where our knowledge has limits, where the universe reminds us, gently, that we're not all seeing, not all knowing, just small creatures with big questions. And that's okay, because here we are, still wondering, still drifting, still holding hands with the stars, even if we don't always understand their language. So come, let's float a little farther, just a little. Do you feel it? Not fear, not confusion. A kind of peace. The peace of being part of something bigger than yourself. Something that doesn't need to end to have meaning. Something that doesn't need answers to be beautiful. Look up one more time. See that shimmer on the farthest edge of sight. That's the boundary of what we know, but not the boundary of what is. And behind that shimmer, well, who knows? Maybe there's more light. Maybe there's a wall. Maybe there's another you, staring back from a different corner of the multiverse. Or maybe, just maybe, there's nothing at all. And that nothing is still part of everything. Let's rest here for a moment. No need to move. Just float. Just be. The universe may or may not be infinite. But this moment, this feeling absolutely is. Let's stay here a while longer, where the stars grow sparse, and the silence becomes more complete. Not because the universe is running out of things, but because space itself is expanding faster than light can chase it. It's hard to grasp this idea that space can stretch so much that it carries galaxies beyond the reach of even light's steady persistence, but here we are, watching entire clusters drift into a kind of forever darkness, still existing, still moving, but lost to us. It doesn't feel cruel or tragic, just vast, inevitable, part of the way the universe breathes. Some galaxies we'll never see again, even if we wait forever, not because they've gone anywhere, but because the space between us and them is growing faster than any message, any beam of light, any whisper from the past can travel. This is where the idea of infinity starts to shift from a numberless stretch into something more emotional, a feeling of unreachability, of a horizon that walks away as you approach, always there, always beyond. And yet, even this unreachable space was once close. Long ago, those galaxies were near enough to be part of our visible sky. But time passed, space grew, and now they're gone, like stars behind a morning sky, still burning but hidden. Drift with me through this quiet. The light here is faint, but it still speaks. It tells us stories about the early universe, about moments when everything was smaller, denser, hotter, and so much closer together. Back then, the universe was like a fire, warming everything at once, no distant galaxies, no quiet cold voids, just light and matter and energy, swirling together in a cosmic soup. And from that heat, from that chaos, came structure. Gravity pulled matter into clumps, and those clumps became stars, and those stars began fusing hydrogen into helium, sending light out into the dark. Then came galaxies, clusters, webs of stars stitched together by unseen hands, and finally, silence, not the silence of nothing, but the quiet after a long and complicated birth. Now, the silence is not empty, it's full of history. Every point of light is the echo of something ancient. Every flicker is a memory. We're not just looking across space, we're looking backward in time, as if the night sky were a storybook, and each star a sentence written billions of years ago. Even the dark between the stars has a story. In those cold gaps, particles pass, waves stretch, fields hum. What looks like nothing is actually full of subtle motion, quantum ripples. Virtual particles flickering in and out, energy that never quite settles. The vacuum of space isn't truly empty, it's restless, even when it seems calm. And this brings us back to the question not just how far does space go, but how deep does it go? What lies beneath the fabric of everything? Is there a bottom, a final thread in the tapestry? Or does the pattern go down forever, fractal and repeating, never arriving at something truly simple? You and I, we're not separate from this. We're made of the same particles, held together by the same forces, warmed by the same starlight that shaped everything else. The atoms in your hand were born inside stars that died long before our sun was born. When you reach out into space, even in thought, you're reaching towards something that's already part of you. So maybe infinity isn't just about size, maybe it's about connection. About realizing that every point in the universe touches every other, not always directly, but through time, gravity, memory, and light. When we wonder if space has an end, maybe what we're really asking is, are we alone? Are we limited? Or are we part of something endless? The idea that space could loop not in a simple circle, but in a grand, gentle curve across dimensions we don't fully understand is more than science fiction. In certain models, the universe could be both finite in size and infinite in experience. Like walking across the surface of the Earth, you can keep going forever without finding an edge, even though the surface is not infinite. If space were like that, a kind of four-dimensional surface curving through a higher dimension, then traveling far enough in one direction might eventually bring you back to where you started. Not because the universe repeated, but because space itself curved. You'd return without ever turning around. No one's found proof of that yet, but we haven't ruled it out either. We just don't know. And maybe that's the beauty of it. The not knowing leaves room for wonder. It invites us to look up night after night and keep asking, keep listening, keep imagining. Because there's still more sky than answers, more stars than stories, more questions than certainties, and that's okay. Let's coast now toward one of those giant voids between galaxy clusters. It looks empty, but it isn't. Dark matter still threads through here, quiet and invisible. Hydrogen gas floats through like wisps of fog. Occasionally, a lone galaxy wanders through the emptiness, like a lighthouse on a sea with no shore. Here, the feeling of infinity becomes almost physical. It presses gently against your thoughts, not heavy or frightening, just persistent. A reminder that there are places we will never reach, distances we will never cross, because space itself is moving faster than we can follow. But even in those unreachable places, the laws of physics may be the same elements, the same forces, the same kinds of stars and galaxies, and maybe even just maybe the same kinds of questions. Could someone else be drifting through a similar thought, on a world we'll never see, looking up at a sky we'll never share, wondering if they're alone in a universe that might never end? We don't know. But the question is beautiful. Let's slow down now. Not because we've found the edge of the universe we haven't, but because something about this moment feels like a place to pause. We've come so far together. From the warm breath of stars to the cold echo of ancient light, from galaxy clusters that stretch across the night like delicate lace, to the quiet voids that lie like soft pillows between the strands. We've flown across space not as passengers, but as participants listening, feeling, wondering. And now, here we are, not at the end of the universe, but at a kind of quiet landing point in our journey. So let's just hover here. Feel the vastness around us, not just as a concept, but as a real, gently stretching thing that holds us in place. You might notice it's not silent in the way a blank room is silent. It's a living quiet, a deep, endless quiet, like the hush that comes right before snowfall, or the moment before a song begins. It's the quiet that lives in the spaces between stars. That lives in us too. Because here's the truth, the one that echoes through everything we've seen. You are not outside the universe. You are not a stranger to it. You are made of it. You are within it, and it is within you. Every breath you take, every thought you have, every heartbeat is part of this cosmic story. When you stared out at the stars as a child, wondering what they were, how far they stretched, whether they ended, you weren't just looking into the sky. You were looking into yourself, into your past, into the atoms that once lived inside suns, into the light that has traveled across ages just to meet your eyes. And even now, even in this imagined drifting we've shared, your thoughts are doing what light does, reaching, exploring, connecting. Maybe we'll never know if the universe is infinite. Maybe it's so big, it may as well be. Maybe it wraps back around in impossible ways. Maybe there are other universes next door hidden behind curtains of energy we can't yet peel back. But one thing we do know is this: we're inside something vast, and we're aware of it. That awareness is rare, precious. The stars shine, yes, but they don't know they're shining. The galaxies spin, but they don't wonder why. We do. And that makes our presence here feel like a kind of miracle. Now imagine yourself standing once again on Earth, beneath the same sky we've floated through. The air is cool, the world is quiet. Above you, stars stretch from horizon to horizon. They're far, unimaginably far, and yet you feel close to them now. You've seen the threads that bind galaxies. You've touched, in thought, the very edge of what we can see. And beyond that, there's still more. That's what the universe offers us. Not certainty, not a finish line, but more. More places to go, more questions to ask, more beauty to notice. Even when we reach the end of what we know, there's always a little bit further we can look, a little bit deeper we can feel. So no, we don't need to find the edge. We don't need to count every star or measure every stretch of space to feel that the universe is something vast and humbling and filled with quiet awe. We only need to notice it, to lie beneath it, to wonder about it. That's enough. Because when we wonder together, gently, patiently, we become part of something infinite, whether or not the universe itself truly is. And as long as we keep wondering, it never ends. So next time you look up, even if it's just for a moment on your way home, take a breath, find a star, let its light settle into you. And remember that no matter what's out there, no matter how far space may stretch, you're already part of it. You always have been. You are not lost in the cosmos. You belong to it. We all do. And maybe, just maybe, that's the most infinite thing of all. Thanks for being here. Thanks for drifting with me. I'll see you in the stars. Good night. But how can that be? Let's take a moment and listen, not with our ears, but with our awareness. Hear the silence of space. It's the kind of silence that lets big thoughts breathe. Now let's float forward, past the moon, which glows like a calm companion, past Mars, with its dusty orange face turned toward the sun, out to the far planets, where sunlight barely reaches. Then beyond even them, where it gets so cold and quiet, you can almost feel time slow down. Here's a question to hold gently in your hands. If the universe is infinite, where are we in it? Are we near the center, near the edge, somewhere in between? Or is there no center at all? It's a strange thought, isn't it? Most things we know have middles and edges. A table, a book, even a long road has a start and an end. But the universe might not. It might be something else entirely, like a surface that folds around itself, or a pattern that never repeats but also never finishes. Let's try to picture that together. Imagine a great ocean with no shore. You're drifting in it, weightless. You can sail in any direction for as long as you like. You never reach land. You never find a wall. Just more water, under more sky. That's one way to think about an infinite universe. But here's the twist: it could also loop back around, like walking in one direction on a globe and eventually returning to where you started. What if the universe wraps itself like that? So you could travel forever, but end up where you began, without ever finding a boundary? Feel the wonder of that as we drift along. Stars pass by like fireflies. Galaxies spin quietly in the distance. Every point you see is full of light, history, and mystery. Yet the farther you look, the more stretched that light becomes. It's like the past whispering from across a canyon. And that brings us to another quiet question. Is there even a limit to how far we can see? Let's pause for a moment. Look out into the deepest part of space visible from here, beyond even the oldest galaxies. We're seeing light that left its home billions of years ago, long before Earth even formed. That light traveled all this way, just to reach us now. Isn't that something? But even that ancient light can't tell us what lies beyond it, because beyond what we can see there may be more. Not just more stars, but more universe. Maybe endless space. Or maybe a limit, but one we can never touch. You see, the universe isn't just big, it's also growing. Imagine blowing up a balloon slowly. The surface stretches. The distance between the little dots on it grows. But there's no real edge to the surface, just more balloon. That's one way astronomers picture space expanding. But we'll leave their tools and maps behind for now. We're just here to feel it. So, let's drift a little farther. Feel the hush of this dark sea around us. You're safe here, weightless, peaceful, a quiet observer in a vast, beautiful unknown. Everywhere we look, galaxies spin like pinwheels. Some are near, like neighbors. Others are so far that their light barely reaches us. And beyond those, there may be more. More light, more space, more mystery. Now reach out your hand just for a moment. Imagine touching the edge of what we can see, the very limit of our cosmic vision. It's not a wall, it's a horizon, like looking out across the ocean from a hilltop. You see far but not forever, and just like the sea, we believe there's more beyond it, maybe much more. You might wonder how we could ever know if the universe is infinite. If we can't go there, and we can't see it, how do we even ask the question? But that's the magic of curiosity. It doesn't need proof to begin, it just needs wonder, and you have that. I can feel it. Now let's drift sideways, turning slowly through the still dark. Feel how the stars change around us. Some get closer, others slip behind. This is the motion of the universe itself. Not just spinning and swirling, but stretching, expanding, growing. But growing into what? That's the heart of it. Let's keep moving gently together through this story. I want you to imagine this. You're floating, slowly, through the velvet dark. No ground beneath you, no roof above. Just a soft, cool quiet that wraps around you like a blanket. You look in every direction, and there are stars, not dozens, not hundreds, but billions. They twinkle, shimmer, and hum softly in your ears, like the gentle rustle of wind in trees back home. You and I were out here, floating together, slowly drifting through space like stardust that forgot where it came from. Right now, above your head, above your ceiling, above the clouds and satellites and shimmering lights of cities, space stretches out. It keeps going, and we don't know where it stops, or if it ever does. Let's ease our way upward. Leave Earth behind the blue and white marble that spins with oceans and storms and dreams. We're passing the Moon now, then Mars, Jupiter with its swirling red eye, Saturn with its delicate, icy rings. We keep going until the Sun looks like just another spark behind us. Now pause here a second. Feel that? That's the silence of deep space. It's not empty, not really. It's filled with things we can barely imagine. Rogue planets wandering without stars, lonely atoms drifting for billions of years, and light that left its home before humans even existed. And that light? It's still on its journey, traveling at the speed limit of the universe, about 186.0 miles per second. Even so, it takes light over 4 years just to get to us from the next nearest star. That's how far apart things are out here. Still with me? Good. Now let's take a slow spin and look around. You'll see the Milky Way stretching across the sky like a brushstroke of milk and silver. Our galaxy, our little corner of everything. It holds maybe 200 billion stars, and that's just one galaxy. Astronomers think there are around 2 trillion galaxies in the observable universe. That's a 2, with 12 zeros after it. Let that settle for a second. 2 trillion galaxies, each one filled with stars, each star with a chance for planets. And on some of those planets, maybe something looks up and wonders the same thing we are right now. Does this ever end? Now here's the thing: we can't see everything. Not because it's too dark, but because light takes time. The farthest things we see are the ones whose light has just reached us after billions of years. That's why we call it the observable universe. It's like living in a fog with a flashlight. We can only see so far, no matter how bright the beam is. So what's beyond that fog? More stars? More galaxies? Or nothing? Scientists think the observable universe is about 93 billion light-years across. That means if you and I stood at opposite ends, it would take light itself over 90 billion years to travel from one of us to the other. And yet, we don't know if that's the whole thing, or just the part our cosmic eyes can see. Some say the universe is flat, not like paper flat, just flat in how space behaves. In flat space, 2 lines can go on forever and never meet. That kind of geometry might mean space continues forever too, no edge, no wall, no end. But others wonder, could the universe loop, like a giant cosmic donut curving back on itself? In a looped universe, if you flew in one direction long enough, you'd end up back where you started, even though you never turned around. It's possible, but we haven't found the proof yet. Still, the universe has tricks up its sleeve, like dark energy. It's the mysterious force that's making the universe expand faster and faster. Not only are galaxies moving away from each other, they're speeding up, like raisins in rising dough. The more space there is, the faster it stretches. And that makes things weird, because if space keeps expanding forever, then some galaxies will drift so far away, their light will never reach us. They'll slip beyond the cosmic horizon like ships vanishing over the edge of a sea we didn't know had an edge. But maybe there's no edge. Maybe it just keeps going. More stars, more silence, more mystery. And if you're still here with me, floating weightless, listening to the faint sighs of galaxies being born and dying, then we're already part of something infinite. Something we may never fully grasp but can still feel. Still curious? Good. Let's keep going. We're heading deeper now, past where even imagination usually hesitates, past the familiar galaxies, past the quiet hum of known physics, into that velvet black space where questions become companions. I want you to feel it all with me, the scale, the silence, the wonder. You might notice something soft brushing by us. That's not wind. It's radiation, the kind that's been traveling since the dawn of time. We call it the cosmic microwave background. It's everywhere. Like the universe's baby picture, this faint glow is more than 13 billion years old. And when we measure its smoothness, its ripples, we're peering into the early structure of the cosmos itself. It's one of the strongest clues we have about the shape of the universe. The data tells us the universe is incredibly flat, not flat like a pancake, but flat in the sense that it doesn't bend back on itself. At least not within the scale we can measure. If it's flat, then it could be infinite in size. Not just very large. Not just hard to wrap your head around. Infinite. Try picturing that with me. Not just more galaxies, not just a sea of stars, but space that stretches with no curve, No edge, no end. You can fly in one direction forever and never hit a wall. No loop, no fence, just more stars. But let's slow down for a second. Let's gently pause on a quiet patch of nothing, or what looks like nothing. We're in a cosmic void now. These are the empty spaces between galaxy clusters. But even here, you'll find stray hydrogen atoms, maybe a rogue planet, flung away from its star. Even in the emptiest space we've found, there's still something. That's the thing. Space isn't empty. Not really. Every cubic centimeter of space contains energy. Even the vacuum buzzes faintly with possibility. Quantum fluctuations, ghosts of particles appearing and disappearing. It's never truly still. Now imagine this. What if the universe we know all 93 billion light years across is just a bubble? Some theories suggest we might be part of a multiverse. Other universes could be forming like bubbles in a vast foam of reality. Some might be tiny, some could have different physical laws, and some, like ours, might feel infinite from the inside. It's only a theory, but a beautiful one. And speaking of theory, do you feel that gentle tension under us? That's dark energy. We can't see it, can't touch it, but it's there, pushing space apart, faster and faster. It's the reason the expansion of the universe is accelerating. Imagine stretching dough, gently, between your fingers. Now imagine the dough stretching itself, faster every moment. That's what dark energy is doing. And it makes up most of the universe, about 68%. Then there's dark matter, invisible, but it pulls galaxies together. That's about 27%. What does that leave for stars, planets, trees, people, cats? Everything we can see? About 5%. That's all. Everything we know made of just a tiny sliver of what's really out there. Reach your hand out. Feel the space around you. Almost all of it is made of things we can't see. And yet we're part of it, floating in the middle of that mystery. Now, let's glance back toward Earth. A soft dot in the dark, fragile, glowing. It's easy to feel small out here. But remember, your brain, your thoughts, your sense of wonder, they are part of this universe. They are the universe becoming aware of itself. Let that land in your chest. You are made of atoms forged inside stars. Hydrogen from the Big Bang, oxygen from dying red giants, iron from supernovae. You're walking stardust. And when you wonder about infinity, that's the universe asking itself a question. So is it infinite? We're now so far from Earth that its light is just a memory, and even the nearest galaxies are becoming smudges on velvet. There's no sound, but don't confuse silence with emptiness. Even here, between the lights, the universe is doing something incredible. It's remembering how to build. Every moment, tiny fluctuations, some of them smaller than atoms, shape the large-scale patterns we see today. That great cosmic web I told you about earlier? It was written into the fabric of space just moments after the Big Bang. Scientists believe that in the first trillionth of a second, the universe expanded faster than the speed of light. They call this idea cosmic inflation. Picture that for a second. The universe, once smaller than a proton, suddenly ballooning into something vast in an instant. A silent flash that built everything we know. That's where space itself came from. That's when time started ticking. Let's glide gently along one of those filaments, long rivers of galaxies, and look at how they curve and thread into one another. They're not just beautiful, they're maps, clues. They show us where gravity has tugged for billions of years, pulling hydrogen together, then stars, then planets. You might notice a galaxy up ahead, not spiraling but shaped like a fat ball. We call these elliptical galaxies. They're old, tired, almost. Most of their star-making days are behind them. But don't skip past them too fast. Some of the oldest stars in the universe live there, billions upon billions of years old. Some formed just after the Big Bang cooled enough to allow hydrogen to come together. And remember, all this time, the universe has been expanding, not like a balloon with stuff on it, but more like the fabric of reality stretching from every point. Wherever you are, it seems like everything is moving away from you. And that's not just a trick, that's how space works. Let's pause and touch a truth that's easy to miss. We're not expanding into anything. Space isn't growing into a bigger space. It's just growing. No edge, no outside, just more of itself. That's a hard thing to grasp, isn't it? But that's the kind of universe we're in. Possibly infinite, possibly finite but unbounded like the surface of a sphere. Except we don't live on a 2D surface. We live inside 3D space, or maybe more. Some theories, bold, strange, and fascinating, suggest that space has more than 3 dimensions. Not just the 3 you can point to, but hidden ones curled up so small that we can't detect them. Like tiny spirals woven into the very air. If those dimensions are real, then the universe could be shaped in ways we can't imagine. Maybe it loops, maybe it echoes, maybe it touches other versions of itself in ways we'll never fully see. But facts are important. Let's talk about what we do know. We know galaxies are flying apart from one another. That was first noticed by Edwin Hubble in the 1920s. He saw that the farther away a galaxy is, the faster it's receding from us. That became Hubble's law. It was the beginning of a huge realization. The universe is growing. We know the age of the universe, about 13.8 billion years, by measuring that expansion, and by looking at the faint echo of the Big Bang, the cosmic microwave background. We know that stars are born from clouds of gas, mostly hydrogen. These clouds collapse under gravity, heat up, and start fusion. That's when hydrogen becomes helium. That's what powers the stars. We know that stars live and die. Some end quietly, like red dwarfs fading to black. Some explode as supernovae, scattering elements across space. That's where carbon comes from, and iron, and gold. You wear the leftovers of exploding stars on your body every day. We know that when big stars die, they sometimes leave behind black holes, points in space, so dense, not even light can escape. But even black holes aren't eternal. They slowly evaporate over trillions of years, releasing energy in what we call Hawking radiation. And yet, for all we know, there's still this question hanging in the dark. Does it ever stop? Is there a wall out there, far beyond what we can see? Scientists have looked for signs, repeating patterns in the cosmic microwave background, strange alignments of galaxies, shadows where another universe might brush against ours, but so far, nothing definite. So maybe the universe goes on, and on. Maybe it loops, maybe it folds, or maybe it just is, in every direction, with no end. That brings us back to you, floating here, drifting through thoughts and facts and stars. You're still part of this story. You, sitting or lying down wherever you are right now, thinking about infinity. That act, wondering, connects you to something ancient. Every time we look up at the stars, we're continuing a tradition that began with the first humans. They looked up and asked, "What's out there?" And now here we are, looking further than they ever dreamed, with telescopes that see in radio waves and X-rays, with instruments that detect gravitational ripples in space, with computers modeling billions of galaxies, all of it just to chase that same question. Let's float beside a strange galaxy now, maybe one shaped like a ring, or a cigar, or a wave. Galaxies come in all shapes. Some have active black holes at the center, blazing with energy. Others are quiet, faint, whispering. We'll drift past it, not to leave it behind, but to make room for more. More questions, more silence, more facts. The truth is, we may never know if the universe is infinite, but here's what we do know. It's generous. It keeps giving us beauty. It keeps surprising us. Let's keep floating. You and I, quiet in the dark, wrapped in starlight and questions. The kind of questions that don't need answers right away. The kind that hum gently in the background, like the glow of distant galaxies. We're deep now, deeper than any spacecraft has ever gone, past Voyager 1, which left the solar system years ago and is still sending whispers back to Earth. Past the Oort cloud, where icy fragments drift like ancient relics. Past the nearest stars, far beyond the furthest probes and plans. And yet, space still stretches. Let's glide toward a globular cluster now, a dense ball of stars huddled tightly together, like embers in a fire. Some of the stars in this cluster are more than 12 billion years old. That's nearly as old as the universe itself, older than Earth, older than the sun. You're looking at ancient light that's been traveling longer than humans have been walking upright. Let that sit with you for a moment. We're not just looking far, we're looking back in time. Every step forward is a step into the past. That's one of the strange facts about space. Distance and time are linked. Light doesn't arrive instantly. It travels, always at the same speed, about 186 0 miles per second. Fast, yes, but not instant. So when you see a star, you're not seeing it now. You're seeing it as it was. That faint star twinkling to your left, its light might have started the journey when mammoths still roamed the Earth. That pale galaxy ahead, its light began traveling long before Earth had oceans. Now tilt your head slightly. See that fuzzy patch up there? That's the Andromeda Galaxy, the nearest major galaxy to us. It's about 2.5 million light-years away. That means the light you're seeing left Andromeda 2.5 million years ago. It's like looking into an old photo album of the universe. And here's a little twist. Andromeda is moving toward us, slowly but surely. In about 4 billion years, our Milky Way and Andromeda will collide. Not in a fiery crash, but a slow, graceful merger. Stars mostly won't hit each other, space is just too vast, but the two galaxies will blend into one larger, elliptical galaxy, a new home for future stars. We're floating inside a universe that is active, even if it looks still. Galaxies collide, stars are born, others die, black holes grow, planets swirl in silence, and all the while, space expands, stretching between the galaxies. Not pulling them through space, but expanding the space itself. Now let's glide toward one of the largest structures in the known universe, a supercluster. Ours is called the Laniakea supercluster, a Hawaiian word meaning immense heaven. It's fitting. Laniakea spans over 500 million light-years and contains around 100 galaxies. And our galaxy, the Milky Way, is just a tiny curl within this great structure. And beyond Laniakea, more superclusters, more structures, arranged in webs and strands and walls. One of the biggest ever found is called the Hercules, Corona Borealis Great Wall. It's over 10 billion light-years across. That means it formed less than 4 billion years after the Big Bang. How did something that massive already exist so early in the universe's life? We're still figuring that out. That's what makes space so humbling and thrilling. Every time we think we've seen the biggest thing, something bigger shows up. Every time we think we understand it all, the universe gives us a gentle shake. Now look down. Below us is a quasar, a galaxy with a supermassive black hole at its core, gobbling up matter and blazing with light. Quasars are among the brightest objects in the universe. Some can shine brighter than 1,000 galaxies combined, and yet they're powered by something so strange: darkness. Black holes. Let's pause and feel one. Of course, we can't really see a black hole, but we can see the effects. The way light bends around it, the way time slows near its event horizon, the point of no return. If you fell in, time would stretch for you, and from your perspective, the universe would flash by in an instant. And here's a thought. The center of most galaxies, including ours, hides a supermassive black hole. Ours is called Sagittarius A. It's over 4 million times more massive than our Sun, and yet it sits silently at the core of the Milky Way, just waiting, holding our galaxy together with its pull. You might wonder what's on the other side of a black hole. We don't know. Some think it leads to a white hole, the opposite of a black hole. Others suggest wormholes, shortcuts through space-time. It's speculation, but it shows how much we don't know, and how much room there still is for discovery. Now feel the space around you again, stretching, expanding, changing. Even atoms aren't eternal. Protons, the building blocks of all matter, might decay one day, trillions of years from now. If they do, then eventually, all matter could dissolve. All the stars would fade, all the black holes would evaporate. What would be left? A cold, dark, silent universe. Still expanding, still emptying, but even then, it wouldn't truly end. It would just keep being. And maybe that's the most haunting, beautiful idea of all, that even when everything fades, space might remain, infinite, quiet, waiting. The silence out here feels different, doesn't it? It's not the kind of silence you find in a quiet room. It's deeper, wider, a kind of silence that seems to stretch in every direction, wrapping itself around your thoughts until you don't know where you end and the universe begins. Now, shift your gaze slightly. See that patch of darkness? It looks like there's nothing there, just empty space. But if you stare a little longer, let your eyes adjust to the ancient shadows. Something begins to form. Faint, soft glimmers. Galaxies. thousands of them, each one home to billions of stars, all hidden in what looked like a blank spot. Astronomers call this the Hubble Ultra Deep Field. They pointed the Hubble Space Telescope at a tiny patch of sky, a patch so small it would look like a grain of sand held at arm's length, and left it there, staring, for weeks. And what came back? Over 0 galaxies, in one tiny speck of sky. Now imagine the whole sky. Imagine how many galaxies are scattered across it. Hundreds of billions, maybe trillions. And that's just the observable universe. That phrase, observable universe, it matters, because we can only see as far as light has had time to reach us since the Big Bang. That's about 13.8 billion years. But because the universe has expanded during that time, the edge of the observable universe isn't 13.8 billion light-years away. It's closer to 46 billion light-years in every direction. Let that sink in. The observable universe is a bubble, a sphere about 93 billion light-years wide, with us right in the middle. Not because we're special, just because light travels at a finite speed, and this is the only part of the universe whose light has had time to reach us. Beyond that, we don't know. There might be more galaxies, more stars, maybe the same as what we see, maybe different, or maybe something entirely new, something that breaks the rules we think we know. Some scientists believe the universe could be infinite, stretching endlessly beyond our horizon. Others think it might be finite but unbounded, like the surface of a balloon. You can walk around a balloon forever and never find an edge, but it's still a limited space. But here's the wild part. Even if the universe is infinite, we'll never be able to observe all of it. Light from the furthest parts might never reach us. There are regions of space receding faster than light, not because they're moving through space, but because space itself is expanding. It's called cosmic inflation, and it happened just after the Big Bang. In a fraction of a second, the universe expanded faster than the speed of light. That initial burst smoothed out the universe and gave us the seeds of the galaxies we see today. We're still riding that expansion. Right now, galaxies aren't just drifting apart, they're speeding away faster and faster. The further away a galaxy is, the faster it appears to recede. Eventually, some will slip past our cosmic horizon, becoming forever unreachable. It's like standing on a beach and watching ships vanish over the curve of the Earth. Except these ships aren't just getting smaller, they're literally being pulled beyond sight. It's humbling. Now let's tilt upward. High above us, in the darkest part of the sky, there's something strange, a cold spot. It's part of the cosmic microwave background, the leftover glow from the Big Bang. It fills the universe like a faint whisper, but this one patch is colder than expected, larger too. Some scientists wonder if it's evidence of something beyond our universe, maybe even another universe brushing up against ours. Yes, some theories suggest there could be a multiverse. Not just one universe, but many, each with its own rules, its own stars, its own beginning, maybe even its own version of you. But we don't know. We don't even know how to test for it, really. Not yet. But just thinking about it, it makes the night feel bigger, doesn't it? Now float with me toward a stellar nursery, a region where new stars are being born from clouds of gas and dust. These clouds are called nebulae, and they're breathtaking. Great swirling tendrils of color, illuminated from within by baby stars. Some are pink and purple, like melted jewels. Others glow a ghostly green or a soft, icy blue. And within these clouds, stars forming, planets forming, solar systems just beginning. The Orion Nebula, not far from Earth in cosmic terms, is one of the brightest. If you look up on a clear night in winter, you can see it as a fuzzy star in Orion's sword. But up close, like we are now, it's massive, over 20 light-years wide, a womb of stars. Reach out your hand. Feel the faint warmth from those newborn stars. They're young, hot, radiating energy in all directions. And here's a fact. Our own sun was born in a place like this, around 4.6 billion years ago. It formed from a cloud of dust and gas, collapsed under gravity, and lit up. And around it, the leftover material clumped into planets. One of them, tiny and blue, would someday grow trees, and oceans, and life, and dreams. You and I are made from the same elements forged in those stars. Carbon, oxygen, iron, all cooked in ancient furnaces and scattered across space when the stars exploded. We are Quite literally, stardust. And that's not just poetry, it's fact. Every breath you take, every cell in your body, comes from something that once lived inside a star. So when we ask, is the universe infinite? Maybe what we're really asking is, how far can this story go? How deep can we dive? How wide can we stretch our minds? You see that faint shimmer ahead, like a soft ripple in the dark fabric of space? We're approaching a gravitational lens. Imagine holding a glass marble in front of your eye, the way it bends light, twists your view. That's what massive objects in space do. When a galaxy cluster sits between us and something even farther away, its gravity warps the light, curving it around like a magnifying glass. So sometimes, we see one galaxy split into arcs, duplicated, stretched into rings of light called Einstein rings. And here's a little known fact. We've seen galaxies so far away that their light left them when the universe was less than 1 billion years old. We're not just looking across space, we're looking back in time. Billions of years, just by opening our eyes. Now float closer. The cluster we're hovering beside? It's called Abell 1689. It's one of the most massive galaxy clusters ever observed. Its gravity is so strong, it bends light from dozens of galaxies behind it. You're looking at a cosmic kaleidoscope images from deep time, wrapped around each other like reflections in a hall of mirrors. It's quiet here, just the faintest glow. And as you drift, notice how everything feels soft, stretched like time itself is a little slower. This is the beauty of space. It isn't loud, it isn't chaotic, it's patient, it waits. Let's turn gently now and move towards something colder. Ahead of us is a rogue planet. No star, no orbit, just a lonely world drifting between galaxies. It might have formed like Earth, in a solar system, and then been ejected, flung out by gravitational chaos. Or maybe it never had a star at all. It's dark here, so dark you can barely see your own hands. But if you reach out, you can feel the planet's frozen breath. Its surface might be hundreds of degrees below freezing. It's sky black, unchanging. And yet inside, deep beneath thick ice, it might have heat. Tidal forces or radioactive decay could keep its core warm, could even melt water, could even host life. We don't know. But some researchers think there might be billions of these rogue planets, wandering alone, invisible, unless they pass in front of stars. They could outnumber stars themselves. So picture this, a galaxy full of invisible worlds, a universe littered with dark, quiet planets, silent travelers on a journey with no sun to follow. Now let's ease ourselves towards something brighter, something explosive. We're arriving at the site of a supernova. Not just any supernova, this one went off just a few thousand years ago. From our perspective, you can still see the shock waves racing outward, glowing shells of gas, expanding into space like fire frozen in time. This star didn't die quietly. It tore itself apart, throwing its guts into the universe. And in the center, a neutron star. It's small, maybe just 20 kilometers across, but heavier than our entire sun. 1 teaspoon of its material would weigh about 1 billion tons. The gravity is so strong that atoms collapse. Electrons and protons fuse into neutrons. It's like a giant atomic nucleus spinning in the dark. Some neutron stars spin fast, really fast, hundreds of times per second. These are called pulsars, and when their magnetic poles sweep past Earth, they blink like lighthouses in the void. Tick, tick, tick. Even out here, in the blackness, there's rhythm. Let's drift a bit more. Feel that? A tug, a low vibration under your skin. We're near a black hole. Don't worry, we're at a safe distance. But its presence warps everything: light, space, time. It's a hole not in the fabric of the universe, but in our understanding. This one is big, a supermassive black hole, probably sitting at the center of a galaxy, millions, maybe billions of times heavier than our sun. Around it, a disk of hot gas spins at near light speed. You can see it glowing, swirling, blazing with X-rays. And even stranger above and below the disk, huge jets of energy shoot out into space. They can stretch for thousands of light years. No one's entirely sure why, but they're real. You're looking at one now, a blue-white jet slicing through the cosmos like a sword. And right at the center, darkness. Not just shadow, a place where space folds in on itself, where time stops. Anything that crosses the event horizon, the black hole's invisible edge is gone. No way back. Not even light escapes. And yet, we think these monsters helped shape galaxies. Their gravity held early galaxies together, helped stars form, regulated how the universe grew. Even destruction has a purpose out here. Let's glide onward. We're passing through a cosmic void now, a region where there are almost no galaxies. These are the great empty spaces between the cosmic filaments, vast, dark bubbles where matter is scarce, but not completely gone. Even here, in the loneliest places, there are atoms, maybe a rogue photon, buzzing around alone since the dawn of time, maybe a dust particle, older than the Milky Way. You might expect silence here, but you'd be surprised. The universe hums not with sound, but with background radiation, a constant faint glow left over from the Big Bang. The cosmic microwave background. We saw a piece of it earlier, but now we're inside its memory, like drifting through the echo of a birth cry. It fills all of space, including here, including you. It's soft, steady, like the universe breathing. And now, look, we're rising again, out of the void, toward the glowing spine of another galaxy. Its arms curl like a dancer in slow motion. Each star a note in a song that's been playing for billions of years. And still we ask, is it infinite? We don't know. We don't. But here's what we do know. Every time we think we've reached the edge of understanding, space gives us more. Another strange star, another faraway world, another ripple in the dark. We're entering a spiral galaxy now. Not ours, this one's about 300 million light-years away, and it's called NGC 7331. It looks a lot like the Milky Way, with those elegant arms spiraling outward from a bright, dense core. But here's the fascinating part. This galaxy is rotating faster than our own. In fact, its outer stars move at nearly the same speed as the inner ones, which shouldn't be possible, according to Newtonian physics. The only explanation we've found? Dark matter. Roughly 85% of the matter in the universe doesn't emit or absorb light. We can't see it, but we know it's there because of how it bends gravity. Galaxies like this one would fly apart if it weren't for an invisible halo of dark matter holding them together. We don't know what dark matter is made of. It doesn't interact with electromagnetic forces, which means it doesn't form atoms, stars, or planets. But without it, galaxies, including our own, couldn't exist. You're floating through the result of invisible physics. And now, let's aim higher toward a structure so massive, it reshapes your idea of scale. This is the Sloan Great Wall, a cosmic megastructure made up of over 100 galaxies. It stretches across 1.38 billion light-years of space. Let that hit you. One single structure, made of galaxies, stars, dust, dark matter, stretching farther than the entire observable distance between us and most galaxies we see. Structures like this are part of the cosmic web, an enormous filamentary network made of galaxy clusters, dark matter filaments, and vast voids in between. The universe isn't randomly sprinkled with galaxies, they're organized, like cells in a body, and we're living inside one of its arteries. Zooming in now, there's a cluster just ahead. It's called the Bullet Cluster. It's actually two galaxy clusters that collided about 150 million years ago. You can see the shockwave, a bright bow-shaped arc of hot gas detected in X-rays. But the most important discovery here? The Bullet Cluster gave us some of the best direct evidence for dark matter. When these clusters collided, the normal matter, the hot gas, slowed down and bunched up. But the gravitational mass, traced by gravitational lensing, kept moving forward. That separation shows that most of the mass isn't invisible matter, it's in the invisible. Dark matter passed through the collision untouched. This one observation shifted the balance in one of cosmology's biggest debates. Now, drift to the side and look out at that glowing red object. It's a quasar, an ultra-bright, energetic beacon powered by a supermassive black hole feeding on material at its core. This one is 3C 273, the first quasar ever identified. Even though it sits 2.4 billion light-years away, it's brighter than hundreds of galaxies combined. Quasars are only visible when their black holes are actively devouring matter. As the material spirals inward, it heats up due to friction, reaching temperatures of millions of degrees, and shoots out beams of radiation across the electromagnetic spectrum. Some quasars are so far away, we're seeing them as they were less than 1 billion years after the Big Bang. That tells us black holes, massive ones, formed incredibly early in cosmic history. Pause here. You'll feel a slight vibration through the void. We've caught the tail of a gravitational wave. In 2015, scientists at LIGO, the Laser Interferometer Gravitational Wave Observatory, detected gravitational waves for the first time, ripples in space-time caused by the collision of two black holes. These waves travel at the speed of light, stretching and compressing space itself. And now we can detect them listening to the sound of space's most violent events. Each ripple tells us about black holes, neutron stars, and things we'd never see with light alone. And in 2017, we saw something even more spectacular, two neutron stars merging. This event, called G170817, gave us both gravitational waves and electromagnetic radiation, confirming that these collisions can produce heavy elements like gold, platinum, and uranium. That's right, the gold in your jewelry? It probably came from the collision of two dead stars. We're not just stardust, we're collision dust, forged in heat, scattered by shockwaves, gathered again into planets and people. Look to your left, that faint streak across the dark? That's a gamma-ray burst, the brightest explosion in the universe. Gamma-ray bursts, or GRBs, come in two types, short and long. The short ones under 2 seconds are caused by two neutron stars merging. The long ones lasting minutes happen when a massive star collapses into a black hole, shooting intense energy in narrow beams. How powerful is a GRB? One burst can release more energy in 10 seconds than our sun will over its entire lifetime. That's 10 billion years of energy, gone in an instant. If one happened close to Earth and its beam hit us, it could strip away our ozone layer. But don't worry, they're rare, and the nearest known GRBs are safely distant. We're just spectators. Now, gently tilt your gaze upward. There, hovering like a ghost, is a planetary nebula. Despite the name, these have nothing to do with planets. What you're seeing is the glowing shell of gas ejected by a dying star, a star once much like our sun. When low or medium mass stars reach the end of their lives, they swell into red giants, then shed their outer layers. What's left behind is a tiny, hot white dwarf, a stellar ember, no bigger than Earth, yet as massive as the sun. The nebula you see, let's say it's the Ring Nebula, will only last about 0 years before fading into the background of interstellar space. In cosmic terms, that's a blink. Each glowing cloud is a whisper from a star saying goodbye. And now, feel that soft tug. We're being pulled towards something much larger, a supercluster. Galaxies are not randomly scattered. They gather in clusters, and those clusters form superclusters. The one we belong to is called Laniakea, meaning immense heaven in Hawaiian. It contains over 100 galaxies, including the Virgo cluster at its heart. But what's most astonishing is that this whole supercluster is moving. We're drifting at about 370 miles per second toward a region of space called the Great Attractor, a mysterious mass concentration we can't fully see because it lies behind the zone of avoidance, where the Milky Way's dust blocks our view. What could be hiding there? Some think it's just a very large collection of galaxies. Others suggest it's part of an even larger structure, the Shapley supercluster, possibly the most massive concentration of matter in our nearby universe. Let's shift again. We're entering a galaxy that's shaped oddly. See how the stars fan out like a tidal splash? That's because this galaxy, NGC 474, has undergone multiple galactic mergers. Gravity is sculpting it in real time. Galaxies grow by eating each other. The Milky Way has done this, and is doing it right now. Several dwarf galaxies are being pulled in and stripped apart by our galaxy's gravity. Streams of stars trail behind them, leaving a kind of cosmic fingerprint. And in about 4 billion years, the Milky Way will collide with Andromeda. Imagine that. Two massive spirals, each with hundreds of billions of stars, spiraling toward one another. But don't picture a crash. Space is mostly empty, so stars will rarely collide. Instead, they'll pass through one another like ghosts, reshuffling into a new galaxy shape, possibly an elliptical galaxy. Now, slow down. Let's hover beside a quiet red star. This is a red dwarf, the most common type of star in the universe. Smaller than the Sun, cooler, dimmer but astonishingly long-lived, a red dwarf can burn for trillions of years. Compare that to the Sun's lifespan of about 10 billion years. These stars are cosmic timekeepers. If the universe lasts long enough, red dwarfs will be the only stars left shining. And many of them have planets. Some in the habitable zone, where temperatures might allow liquid water. We've discovered thousands of exoplanets already, planets orbiting stars outside our solar system, and we're finding more every week. One of the most famous systems is TRAPPIST-1, which has 7 Earth-sized planets, 3 in the habitable zone. It's just 40 light-years away, close by cosmic standards. The star is small and dim, but those planets could have oceans, clouds, maybe even life. We don't know. But every discovery like this reminds us the universe isn't just vast, it's full of possibilities. We've entered a part of the sky where starlight fades. Here, darkness presses in from every side, soft and deep like velvet. But don't be fooled, this isn't emptiness. You're looking at a dark nebula, a cold cloud of gas and dust so dense, it blocks out the stars behind it. Breathe in and feel the silence here. This is a place of beginnings. Inside these dark clouds, atoms gather, slowly, invisibly, until gravity takes hold and a new star is born. The Orion molecular cloud where we are now is one of the closest stellar nurseries to Earth. It's just over 1,300 light-years away, and it's creating hundreds of new stars right now. Reach out with your mind and feel the weight of that gas, hydrogen and helium. Mostly. In some places it's just a whisper. In others, it's thick enough to see against the sky. Deep inside, pressure builds until atoms begin to fuse. And then in a moment so quiet you'd miss it, a new light blinks on. You've just witnessed stellar birth. Now let's glide gently through the trapezium cluster, tucked inside Orion's nebula. Look around. See those young stars burning hot and blue? They're no more than 2 million years old babies, in stellar terms. Their light is fierce, and it sculpts the gas around them, carving out cavities, setting off shockwaves, triggering even more stars to form nearby. We're floating through creation itself. But let's pull back higher, farther, colder. There's a faint point ahead. That's not a star. That's the Andromeda Galaxy. It looks small from here, but it's massive, 1 trillion stars, about twice the number in our own Milky Way. And we're falling toward it. Yes, our 2 galaxies are locked in a slow dance, closing in at 68 miles per second. In 4 billion years, we'll merge. Picture it. Stars slinging past one another, nebulae glowing from new bursts of star formation, black holes spiraling into one another, until they unite with a final, quiet ripple through space. You'll still be part of it. Every atom in you will still exist, folded into some new story. Now look down. See that glittering trail? Those are rogue planets, worlds without stars. Flung from their systems or born adrift, these planets travel alone through space. There may be billions of them in our galaxy. Some are icy. Some may be warm beneath thick atmospheres, heated from within by radioactive decay. Can you imagine standing on one? The sky would be pitch black. No sun, no moon, only stars above. And yet, below your feet, there could be oceans, winds, maybe even something living. We don't know. But the mystery pulls us, doesn't it? We're always looking for what might be out there. Just ahead, there's a massive red storm swirling on a giant planet. It's Jupiter's great red spot, 3 times the size of Earth, spinning for at least 400 years. Listen, you can almost hear the winds howling, over 400 miles per hour. Feel the weight of it. Jupiter holds 318 times Earth's mass, and it's made mostly of hydrogen. It doesn't have a solid surface, just layers of gas and liquid getting denser and hotter as you fall deeper. Eventually, the pressure becomes so intense that hydrogen turns into a liquid and then maybe into metallic hydrogen, which might create its enormous magnetic field. Now close your eyes for a moment. Beneath Jupiter's clouds, deep in its hidden heart, might be a rocky core. No one knows for sure. We sent the Juno spacecraft to find out, and it's still sending data, orbit after orbit. Even here near something so huge, we're still surrounded by mystery. And to the side, Saturn, elegant, pale gold, wrapped in those iconic rings. But do you know what the rings are made of? Ice. Billions of particles, from dust grains to house-sized chunks, reflecting sunlight as they orbit. The rings are young, maybe only 100 million years old, which means the dinosaurs never saw them. And one day, they'll be gone. Gravity pulls them inward. Saturn's rings are slowly falling, like glitter settling through an ocean. In another 100 million years, they might vanish altogether. We just happen to be alive at the perfect moment to see them. Lucky us. Let's coast outward now, far past Neptune, past the Kuiper belt, where icy bodies drift in twilight. There's Pluto, small and distant, with a frozen, heart-shaped plain made of nitrogen ice. It has mountains of water ice and a blue haze in its thin atmosphere. Pluto is not just a cold rock, it's alive with geological activity. And beyond Pluto, a deep chill. The Oort cloud is weighting a sphere of icy debris surrounding our solar system like a shell. We haven't seen it directly, but we think it holds trillions of comets, stretching out nearly 100 astronomical units. That's almost 1.9 light-years away. The outer edge of the Oort cloud marks the border of the sun's influence. Beyond that, the galaxy pulls harder than our star does. And yet, even here, far beyond sunlight, far beyond what any of our spacecraft have touched, you're still not at the edge of the universe. There may be no edge. That's the strange thing. We call it the observable universe because it's defined by how far light has traveled since the Big Bang, about 13.8 billion years. But because of the expansion of space itself, the edge of what we can see is now 46.5 billion light-years away in every direction. Beyond that, we don't know. But if the universe is infinite, truly infinite, then there are infinite galaxies, infinite stars, and even infinite versions of you. Not in the science fiction way, but in the quiet, mathematical truth that, in an endless space with finite arrangements of particles, repetition becomes inevitable. Let that sink in. Somewhere, out there, might be another version of you floating here with me asking the same question. Is the universe actually infinite? Now imagine you're drifting silently above a giant stretch of nothing. That might sound empty, but this nothing has a name: the Boötes void. It's one of the largest known empty regions in the universe. A cosmic bubble, about 330 million light-years across, with almost no galaxies inside. Picture it, hundreds of millions of light-years of silence. And yet, even here, something exists. Sparse, quiet galaxies, scattered like distant whispers, still float inside the void. Scientists once called it the Great Nothing, and for good reason. It's strangely alone. In a universe so full, places like this feel impossible. But space isn't evenly packed. It's a web, a cosmic web. Look around you now, and you'll start to see the pattern. Galaxies aren't spread randomly. They cluster along vast, invisible threads, highways made of dark matter, where gravity pulls ordinary matter into place. These threads form filaments, which connect to clusters, which surround more voids. Imagine a sponge, or a three-dimensional spiderweb stretching across all of existence. That's the shape of the universe. And speaking of dark matter, you can't see it, but it's everywhere. About 27% of the universe, in fact. It doesn't glow, reflect, or block light. But it tugs on galaxies, bends starlight, and holds clusters together. Right now, even here beside me, it's passing through you. That might sound spooky, but don't worry. Dark matter doesn't interact with you the way ordinary matter does. It doesn't push or pull or burn. It's quiet, invisible, fundamental. We know it's there because galaxies rotate faster than they should. Without something unseen holding them together, they'd fly apart. And then, there's dark energy. It's even more mysterious. It's what's causing the universe to expand faster and faster. Not just coasting, but accelerating. More than 68% of the universe is this strange force, and yet we barely understand it. Imagine blowing up a balloon. You'd expect it to slow down as the rubber stretches, right? But instead, the balloon begins to grow faster the more it stretches. That's what dark energy is doing to the universe. Now, hold on to that image, because I want you to float with me even farther. We're passing through the Hubble Deep Field, one of the most profound views ever captured. It started as an empty patch of sky in 1995, The Hubble Space Telescope stared at that patch for 10 days. The result? Over 0 galaxies, in just a speck of space smaller than your fingertip held at arm's length. Think about that. Thousands of galaxies, each with billions of stars hiding in a single dark corner of the sky. And that's just one spot. Multiply that by the entire sky, and you start to get a sense of the scale. There may be over 2 trillion galaxies in the observable universe. 2 trillion. And every time we look deeper, we find more. Some of those galaxies are tiny and irregular. Others are majestic spirals like our own Milky Way. Some are elliptical galaxies, big and ancient, filled with old stars and little gas. Some are starburst galaxies, lit up with newborn stars, glowing with ultraviolet heat. There's Messier 87, a supergiant galaxy in the Virgo cluster home to a black hole so massive, we've photographed its shadow. Remember that black circle surrounded by glowing orange in 2019? That was it. That's where you're floating now. And speaking of black holes, let's visit one, carefully. The closest one we know of is about 1/600 light-years from Earth. It's in a binary system called Gaia Bione. The black hole itself is silent. You wouldn't see it only the way it pulls on the star beside it, like a ghost partner in a cosmic dance. But let's go deeper to the heart of the Milky Way. There, buried beneath clouds of dust and stars, is Sagittarius A, a supermassive black hole about 4 million times the mass of our Sun. And we've seen stars orbiting it, curving in loops at incredible speeds. It's like watching gravity itself roar, invisible, undeniable. And yet, it doesn't suck everything in. Most of space near it is just that space. If the Sun were replaced by a black hole of equal mass, Earth would keep orbiting it as usual, just in darkness. Strange, right? Let's coast outward again, but this time, imagine touching a neutron star. These are the remnants of exploded stars, tiny, dense cores no bigger than a city, but so heavy that a teaspoon of material would weigh 1 billion tons. Let that settle into your mind. The gravity here is so strong, it warps space and time. The surface is a crust of atomic nuclei over a liquid sea of neutrons. And some spin incredibly fast pulsars, flashing beams of radio light like cosmic lighthouses. The fastest spin, hundreds of times per second. You can hear them tick, 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 like the heartbeat of the universe. Now reach out and imagine dipping your hand into a star. That would be our Sun, the closest one to us. Its surface, the photosphere, is about 500 degrees Celsius, but that's nothing compared to its core. In there, temperatures reach over 15 million degrees, hot enough for hydrogen atoms to fuse into helium and release energy. That fusion is what powers everything. Every tree, every breath, every flicker of life on Earth powered by fusion happening right now, 93 million miles away. You're warmed by the light of an ancient reaction. And the Sun is just average. There are red dwarfs, smaller and cooler, that live for trillions of years. And blue giants, massive and hot, that burn out in just a few million years, ending in supernovae, those brilliant explosions that scatter elements across the galaxy. Every atom in your body heavier than hydrogen? It came from a star that died. You are literally made of stardust. And now, we look ahead again. The universe is expanding. Every second, space itself grows. Galaxies beyond a certain distance are moving away faster than light, not because they're speeding, but because space is stretching between us and them. Eventually, in billions of years, distant galaxies will disappear from view altogether. The universe will grow quiet, cold, dark. But we're not there yet. Right now, in this moment, you and I are floating in the richest era the cosmos has ever known. We can still see the light from the Big Bang. We can still watch stars being born. We can still feel wonder. And yes, we can still ask, is the universe actually infinite? Now picture yourself approaching a glowing cloud, soft and enormous, with tendrils of gas curling like smoke through the dark. This is a nebula, a stellar nursery, the kind of place where stars are born. This one is called the Orion Nebula, and it's just over 1/300 light-years from Earth. Not that far, in cosmic terms. But as we drift into its folds, notice the color dusty rose, electric blue, deep violet, tinged with starlight. The gas here, is mostly hydrogen, the most abundant element in the universe. And it's not just floating, it's becoming something. New stars are forming. You might see one now, a tiny point of brightness, still hidden behind a veil of dust. It's just a baby, gathering mass, slowly heating up. In a few million years, it will ignite. For now, it rests in a cradle of glowing gas. And around it, swirls of material, spinning slowly. These are protoplanetary disks, the early ingredients of planets. Some of them may become rocky, like Earth. Others could become gas giants, like Jupiter. Some might hold water. Some might, just maybe, hold life one day. Lean in and listen not with your ears, but your sense of imagination. You might hear the low hum of particles colliding, the whisper of light pushing against dust. It's peaceful here, but full of motion. Stars aren't born with fire and fury, they start quietly, like a flicker waiting for air. And these nebulae? They're all over the galaxy. The Eagle Nebula, famous for its pillars of creation, where long columns of dust rise like skyscrapers in space, or the Carina Nebula, home to massive stars in violent stages of growth. These are more than pretty clouds. They're the galaxy's way of building the future. Let's pull back now, just enough to see the bigger shape of the Milky Way. We live in a barred spiral galaxy, wide and flat, with swirling arms that wrap around a central bulge. It's about 100 light-years across, and we're nestled in one of the arms, the Orion Arm, quietly spinning around the center. It takes our solar system about 230 million years to complete one orbit of the galaxy. Just imagine that. Every step of life on Earth, from the first single-celled organisms to this very moment, has happened during a single trip around the galactic core. And in that center, a supermassive black hole, of course. It's calm now, but it wasn't always. The centers of galaxies can flare with energy when matter falls into black holes. These flares can outshine everything around them. Galaxies like that are called quasars. Let's glide over to one. Look there, that distant smudge, brighter than 1 trillion suns. That's a quasar. The black hole at its heart is feeding, pulling in gas and dust, heating it up to incredible temperatures. The light you're seeing traveled for billions of years to reach us. It's not just old, it shows us the past. That's something incredible about space. The farther you look, the older the light. Our universe doesn't just stretch across space, it stretches through time. Some of the stars you see now, they don't exist anymore. Their light is still traveling, but the stars themselves are long gone. Now let's pause. Take a breath. Out here, it's easy to forget where we started, a small planet, circling a small star, in a quiet corner of a galaxy. But Earth is no less wondrous. We orbit at just the right distance to have liquid water. We have a protective magnetic field, a moon that stabilizes our tilt, an atmosphere that traps just enough heat. All of this feels rare. And yet, the universe is big. There are at least 300 billion stars in the Milky Way alone, and probably trillions of planets. Some, like Kepler 186, lie in the habitable zones of their stars. That means they might have conditions for life. What kind of life? We don't know. It might be microbial, or it might be something we can't even imagine, life that breathes methane, or floats in clouds, or glows in the deep of an alien sea. The possibilities are endless. And here's the wild part. There may be more Earths than there are grains of sand on every beach on our planet. More Earths than all the footsteps ever taken. More potential homes, waiting in the dark. Are we alone? We don't know that either. But when you look up, remember, you're staring into a crowd. Let's zoom out even further. We've explored nebulae, stars, galaxies. But galaxies don't just float alone. They cluster together in groups and superclusters. The local group is where the Milky Way lives, about 80 galaxies bound by gravity. And beyond that is the Virgo supercluster, a sprawling family of galaxy clusters. But wait, go further still and you'll see the Laniakea supercluster, our true cosmic address. Over 100 galaxies, all flowing gently toward a region called the Great Attractor, a gravitational focal point whose exact nature is still unknown. And here's where it gets strange. If the universe has structure, and that structure ends, what's outside of it? We don't know. The observable universe is about 93 billion light-years across. That's how far light has been able to travel since the Big Bang. But the universe might be much larger, maybe infinite. Some theories suggest the universe could be curved, not like a ball, but like the surface of a saddle or even a loop. Others propose it's flat and infinite, stretching forever. Still, others suggest it's part of a multiverse, where different regions have different physical laws. And us? We're a ripple, a tiny wrinkle in a vast cosmic fabric. Yet, we can understand it. We can look into the past. We can ask questions no other species that we know of has asked. Like, what came before the Big Bang? Maybe nothing, maybe everything. Some scientists think the Big Bang wasn't a beginning, but a bounce, a universe collapsing and rebounding. Others think it was a quantum fluctuation, a spontaneous bloom of energy in space from a vacuum. Let that float in your mind, something from nothing. That's what the early universe was. Dense, hot. In a fraction of a second, it inflated faster than the speed of light, then cooled, expanded, and formed the building blocks of all matter. And that early light? It's still here. It's called the cosmic microwave background, or CMB, a faint glow, just a few degrees above absolute zero, stretched across the entire sky. It's not visible to your eyes, but it's everywhere, a soft echo of creation. Close your eyes. Feel it. It's older than stars, older than galaxies, older than time as we know it. You and I are floating in its warmth right now, leftovers from the birth of the universe itself. Let's continue drifting, just you and me, starlight on our faces, silence brushing past like velvet. No rush. The universe doesn't hurry, and neither do we. Look around you now. We're passing between galaxies, through intergalactic space. It feels empty here, doesn't it? Like there's nothing at all. But that's not true. Even in these vast gaps, there are whispers, lone atoms of hydrogen, ancient light still gliding past, faint radiation left over from the birth of everything. It's quieter here, yes, but not lifeless. Now tilt your gaze upward or outward or in whatever direction makes sense, since space doesn't really have an up or down. Ahead of us, the light from another galaxy cluster reaches us, flickering like a field of distant fireflies. Each of those tiny dots, billions of stars, trillions of planets, in every direction. Let that sink in for a second. In every direction. And here's a fact that's both strange and beautiful. The universe looks roughly the same in all directions. That's called isotropy. No matter where you turn your eyes, the large-scale structure of the cosmos is consistent. There are no edges, no corners, no walls. Just a smooth, even spread of galaxies, stretching beyond what we can see. Now, does that mean the universe is infinite? We don't know. But we know this. We can't see the end of it. We call the part we can see the observable universe, and its size isn't limited by how far light can travel alone. It's also shaped by how the fabric of space itself expands. Light from far-off galaxies travels toward us while space itself stretches out, carrying those galaxies even farther away. Imagine swimming upstream in a river that's growing wider every second. That's what light is doing, trying to reach us through a universe that's expanding faster than light can move through it. Yes, the expansion of space can move faster than the speed of light. That's allowed. Nothing in space can travel faster than light, but space itself can do whatever it wants. And it does. You've probably heard of redshift, the way light from distant galaxies shifts toward the red end of the spectrum. It's not just Doppler effect, like with sound. It's space itself stretching that light out as it travels. The farther a galaxy is, the more its light is stretched, and the redder it looks. So we see galaxies rushing away from us, the farther the faster. That led to one of the most profound discoveries in science. The universe is expanding. And if it's expanding now, it must have been smaller once. That's the foundation of the Big Bang theory. But the Big Bang wasn't an explosion in space. It was an explosion of space everywhere, all at once. There was no center. Every point in space was once part of a hot, dense, glowing whole. Even now, as we float here in the quiet, that expansion hasn't stopped. Galaxies are still moving apart. Some are rushing away so fast, their light will never reach us. They've already passed beyond the cosmic horizon. Think of that. There are places we can never see. Not now. Not ever. Not because they don't exist, but because they're simply too far, receding faster than light, like ships sailing into a sea that keeps pushing them outward. And still, We wonder if the observable universe is 93 billion light-years across. What lies beyond? There's no clear answer. Maybe the universe is finite but unbounded like the surface of a sphere, only in 3 dimensions. If you kept going in a straight line, you might eventually return to where you started, just like circumnavigating the Earth. Or maybe the universe is truly infinite, stretching on forever, with no edge, no border, no end. If that's true, then the implications are staggering. In an infinite universe, every possible arrangement of particles must happen somewhere, which means that somewhere, out there, there could be another version of you, sitting on another version of Earth, listening to this same quiet story, not once, not twice, but infinitely many times, in infinite variations. It's a wild idea, but the math doesn't rule it out. Let's pull back a little, breathe in the stillness. Imagine that we're looking at the cosmic web, the true structure of the universe on the largest scale. Galaxies don't spread randomly. They form patterns, thin threads and knots, like a vast 3D spiderweb woven across time. In the gaps between the threads, there's almost nothing, immense voids, sometimes hundreds of millions of light-years across. But in the dense knots, that's where galaxies cluster. That's where superclusters form. That's where gravity has drawn matter together like clay around invisible hands. This structure didn't happen overnight. It began with tiny fluctuations in the early universe, ripples in density, so small we can barely detect them. Over billions of years, those tiny ripples became stars, galaxies, and clusters, all from simple gravity. And here's a strange twist. We don't see most of the matter that formed this structure. We can measure it, but not see it. That's because most of the universe, about 85%, is made of something we call dark matter. It's not dark like shadows. It doesn't absorb or emit light. It's invisible, but it has mass, and it bends gravity. We can watch how galaxies spin, and they spin too fast to be held together by the stars and gas we can see. Something unseen is pulling on them, something massive. That's dark matter. And that's just the beginning. There's also dark energy, even more mysterious. About 70% of the universe seems to be made of this stuff. It doesn't clump like matter does. Instead, it causes space to expand faster. It's like a gentle push baked into the fabric of the cosmos itself. We don't know what it is. Not really, but it dominates the fate of everything. So if you're counting, about 5% of the universe is normal matter stars, planets, you, me, coffee, trees, everything we've ever known. The other 95%? Still a mystery. Now imagine this. The universe might keep expanding forever, growing colder, emptier, quieter. Galaxies will drift so far apart they'll fade from view. Stars will burn out. Black holes will evaporate. And in the far, far future, the universe could end, not in fire, but in silence. That's the heat death scenario. But there are other endings too. Some believe the universe might reverse course and collapse the Big Crunch. Or perhaps it'll tear itself apart in a big rip, where space expands so violently that even atoms are pulled apart. No one knows. And yet, here we are, 2 travelers, riding a gentle stream of thought through all of it. Here's something incredible. The farther away we look, the older the light we see. So every time we spot a distant galaxy, we're seeing it not as it is now, but as it was when that light left it sometimes billions of years ago. Right now, we're looking at galaxies so distant. Their light began its journey when Earth didn't even exist. Not a single tree, mountain, or ocean, just darkness. Isn't that amazing? Space is like a time machine. The farther we gaze, the deeper into the past we peer. If you stretch your eyes as far as they'll go, well beyond the galaxies, beyond the voids, you reach something even more ancient. The cosmic microwave background. It's the faint afterglow of the Big Bang itself. A soft, invisible light that's been traveling for nearly 13.8 billion years. It's everywhere. Right now, it's even passing through you. If your eyes could see microwave radiation, the whole sky would glow with it, not with stars, but with a uniform, gentle fog. This fog is cold, just a few degrees above absolute zero. But it holds secrets. In its tiny fluctuations, we can read the earliest moments of the universe. From that faint glow, scientists learned how fast the universe is expanding, how much matter it contains, and even clues about its shape. And yes, the shape of the universe is a real question. Is it curved like a ball, or shaped like a saddle, or flat, like a never-ending plane? Right now, the evidence says it's flat or very, very close to it. That means parallel lines don't converge or diverge as they travel through space. They just keep going, side by side, forever. Flatness suggests something wild. If the universe isn't curved inward, it might go on forever. But we still don't know. There could be subtle curves too big for us to detect. Or maybe the universe is infinite, but with a twist. Imagine a video game map that loops when you go too far to the edge, walk far enough east, and you end up back where you started. Some theories suggest the universe might be like that, finite but unbounded. No edges, no walls, just a closed loop in higher dimensions. We haven't found evidence for that, no repeating galaxies, no doubled stars, but we keep looking. Let's hover here a moment, right on the edge of the known. Beneath us, a swirling galaxy spins slowly. Each arm is filled with stars, gas, and dust, entire solar systems drifting like autumn leaves. If you zoomed in close enough, you might spot planets forming, clouds collapsing into stars, ancient suns dying with quiet dignity. And maybe, just maybe, someone else out there, watching their own sky and wondering the same thing we are. Is this all there is? Or is there more? Let's look at something quietly extraordinary. The principle of cosmic homogeneity. That's a fancy way of saying that, on a very large scale, the universe looks pretty much the same everywhere. If you zoom out far enough, no matter where you go, the patterns repeat. That's one reason we think it might be infinite. If there's no edge, and the same structure continues in all directions, then why would it suddenly stop? But here's a humbling truth. We can't ever observe the entire universe. Not even close. We're limited to what light has had time to reach us, the observable universe. What lies beyond that horizon? We don't know. There could be more galaxies, or different laws of physics, or no galaxies at all, just a silent ocean of void. And some theories, especially those linked to inflation, suggest something even more mind-bending, that our universe might be just one bubble in a multiverse. Yes, a vast, frothy sea of universes, each with its own rules. Some could be almost identical to ours. Others might be impossibly alien, no matter, no light, no time as we understand it, just otherness. We don't know how to prove that, not yet, but it's an idea that serious physicists take seriously. And in some versions of the multiverse, the total cosmos is infinite by definition. Our universe is just one patch in an endless quilt. Pause with me here. Feel the weight of that possibility. Not just infinite space, infinite realities. It's almost too much to hold in the mind. But you don't need to understand everything. That's the beauty of being here, just floating, observing, breathing in the mystery. You and me, two small voices in the great dark, wondering. Let's touch another fact, this one about gravity. It's not just a force pulling objects together. It's the shape of space itself, bending in response to mass. You don't fall toward the Earth, you slide along a curve in space. Planets don't orbit because they're being pulled. They move along twisted paths carved into the fabric of the cosmos. This idea, from Einstein, changed everything. It means that massive things, stars, galaxies, black holes can warp the space around them. They can even bend light. That's why we see distant galaxies distorted like funhouse mirrors. Their light is passing near something heavy and curving around it. We call this gravitational lensing, and it lets us peek at things we couldn't otherwise see. Sometimes, a galaxy acts like a lens and magnifies something even farther away behind it like a cosmic telescope. Through these lenses, we've glimpsed the earliest galaxies ever born. That's another fact. The first stars were nothing like our sun. They were huge, bright, and burned fast. We call them population 3 stars, and we've never seen one directly. They lived and died before our solar system even existed. But they seeded the universe with the elements of life: carbon, oxygen, nitrogen, iron. Every atom in your body came from a star that died long ago. In that sense, you're not just in the universe. You are the universe, thinking about itself. And that's a fact. Let's keep moving. The darkness ahead? That's no ordinary blackness. It's the edge of a void, a region of space with almost no galaxies. These voids can span hundreds of millions of light years, vast and nearly empty. Not completely, of course. There are still atoms here, still dark matter, still faint whispers of light. But compared to the glowing webs behind us, this is silence. Float with me into it. No gravity tugging you strongly one way or another. Just equilibrium, just peace. And here, in the middle of nothing, the question returns, is this emptiness endless? Or is it the pause before something new?